yesterday. So we're multiplying binomials, all right, which is basically all we did with this activity today. Now, the first method for multiplying binomials, like I mentioned, was box method. So you can make a note off to the side of your journal about box method, which is essentially making a box. If you had, say, A plus B times C plus D, you would write it as A plus B across the top, C plus D along the side, and then multiply row by column. So A times C would be AC, B times C would be BC, A times D would be AD, B times D would be BD. And then you just pull everything out, combine like terms when needed. Now, the other method that your journal is mentioning is what we call FOIL. All right. FOIL is an acronym, and I'm going to explain what that acronym means in just a second. Now, both methods work. All right. It's up to you how you want to do it. However, my preference is box method. I just like box method because it's more visual, it's more organized to me. Some of you may like FOIL more. That's okay. You can use either method. I don't care which method you use, as long as you can use it effectively. All right. So with FOIL, it's an acronym. FOIL stands for first, outer, inner, and last. And basically what that means is that if you're looking at the binomial, it's almost like distributing, but with specific terms. You would multiply the first two terms of each polynomial. So you multiply the first term of each binomial together. So that would give us AC. Then you would multiply the two outer terms, so B and D in this case. So those are the last ones. Nope. The outer terms are the ones on the very ends. They're not next to each other. So that would be AD. Then you would multiply the two inner terms. So the ones that are directly next to each other but are not in the same parentheses. That would be BC. And then the last two terms of each polynomial. That would be BD. And then same thing with box method. You just add them up, combine like terms. So again, some people like FOIL. Some people like box method. It's up to you which one you use. I would suggest for right now, try out both, see what you like, and then stick with the strategy that you like. Again, I don't care which method you like better. You can use either one. If it was on a test and you used FOIL instead of box method, I'm not going to take off points for that if you still get the correct answer. All right? I'm not testing you on whether you can do both methods. I just care if you can do it. All right? So let's look at example 7. All right? I'm going to do this one with FOIL. All right, since we already did like technically one example with box method in our lesson today. Heads up, please, guys. All right, so I'm first going to do my first terms. So I'm going to multiply my first two terms, or x times x. What's x times x? So think algebra tiles. It's x squared. Then I'm going to do my outers. So that's my x and my 7. I'm going to multiply those two together. What's x times 7? 7x. So this would be plus 7x. Then I'm going to do my innards. So the 6 and the x. I'm going to multiply those two together. What's 6 times x? Think algebra tiles. If you had 6 ones and a singular x, you would end up with 6x bars. And then lastly, my last. All right. So 6 times 7. What's 6 times 7? 42. So if we used FOIL, that would be the polynomial that we get from that. However, is that my answer? No. Why? What do I have to do next? Combine the like terms. Where are my like terms? 7x and 6x are my like terms. So I'll bring down the x squared plus, what's 7x plus 6x? 13x. And then bring down the plus 42. Now we got our answer. And you could have gotten that exact same answer if you did box method. All right. So that was foiling. Now for number 8, or the next example, let's try that one with box method. All right. So if I'm doing a binomial by a binomial, what's the size of my box going to be? So 2 terms by 2 terms. So my box will be a what? A 2 by 2 box, right? So if you're doing 2 terms by 2 terms, your box should be a 2 by 2. So when you draw your box, that means it should have 2 rows, 2 columns. All right. So you should have 4 little boxes in the middle. Then it doesn't, like, just like with algebra tiles, it does not matter which side you put your terms on. So I'm going to put a minus 4 on the top and a plus 9 on the sides. My recommendation to you is keep the signs with the number. Right, make sure you write the signs down, because when you're multiplying, you may forget about that negative. All right. And now we're going to do just like we did with algebra tiles. We're going to do column by row. So we're going to start with this box. If I'm doing this box, what am I technically multiplying together? What 2 values am I multiplying together here for the yellow box? I'm doing what? It's like a squared. Right. We're doing a times a. So we're doing a times a for this box, which means we get a squared. What about for this box? What are we multiplying together for that box? Sandro. Negative 4 and a, which just like he said, does give us negative 4a. What about this box? What am I multiplying together? 9 and a, which that does give us 9a. And then finally, this last box. What am I multiplying together? The 9 and the negative 4. So if I multiply those two together, what does that give me? Negative 36. Now, only difference between box and foil is that box is just kind of a little bit more organized. All right. Now, all I got to do is pull my terms out of my box and combine like terms. So if I pull all my terms out and write them out, I get a squared minus 4a plus 9a minus 36. Now, I'm not done. What do I need to do? Combine the like terms. Where are my like terms here? Negative 4a and 9a. So I bring down the a squared. What's negative 4a plus 9a? positive 5a, and then I bring down the minus 36. So this would be my answer. All right. Let's try another one. So let's look at example 11. Do you guys want me to foil or box this one? I'll let you guys pick. What do you want me to do? So do you want me to foil it or do you want me to box it? It doesn't matter. You want to foil? All right. So we'll foil this one. So I would do first. So multiplying first by first. So what's 5y times y? So guys, if you had 5 x's across the top and 1 x along the side and you multiply them together, what would you get? 5y squared. Good. You end up with 5x squared if you're thinking algebra tiles. What about if I did my outers? So 5y and 4. What's 5y times 4? 20y. Innards. So negative 2 times y. What's negative 2 times y? Negative 2y. And then lastly, my last. Right, negative 2 times 4 is negative 8. Then we just combine like terms, which are only my singular y's. So this would be 5y squared. 20y minus 2y is what? Positive 18y minus 8. All right. One more. So let's look at number 12. Now, number 12 is a little bit different than what we've been doing. What's the difference? There's an extra term. So in reality, we're multiplying a binomial by a what? What's this type of polynomial called? It's a trinomial. So we're multiplying a binomial by a trinomial. Now, if you're multiplying anything larger than a binomial to another binomial, this is one where you have to use box method. So if you're doing one that looks like this or bigger, so binomial times trinomial, trinomial times trinomial, heads up please guys. You have to use box because you could technically foil this, but it gets really, really, really messy. And a lot more often than not, students forget terms. So I highly recommend a box. So if I'm making this box, we're doing a 2-term by a 3-term. So how many little boxes do you think I'm going to have in this box? So think about it. If we're doing a 2 by 3, that means we have to have 2 rows, 3 columns. So we should have 6 little boxes. And we're just going to do the same setup. It's just a little bit bigger. So 2f minus 9 on the side, 3f squared minus 5f plus 6 along the top. And it's just like if we're doing a 2 by 2 box. Same method. All right. Now think about this carefully. This first box, we're doing 3f squared times 2f. What's 3f squared times 2f? 6f, not squared, cubed. Remember your power rules. If this is a 2 and this has an exponent of 1, you add them. So that would be f cubed. So 3 times 2 is 6. F times f squared is f cubed. What about this box? Right, negative 10f squared. You do negative 5f times 2f. So you just get negative 10 because 2 times negative 5, and then f squared. What about 2f and 6? So that would make up this box right here. So it's not 12 squared, but 12f, because 6 doesn't have an f on it. So we just slap the f on at the end. So 2 times 6 is 12, and then there's no other f, so we just add an f. What about this box? Actually, so 3f squared times negative 9. All right, what would that give you? Good, negative 27f squared. So there's no f connected to the negative 9, so we just slap on whatever type of f the other term has. What about negative 5f times negative 9? Sure, it's negative? Positive 45f. Because negative times a negative is a positive. And then lastly, this one. Negative 63. That's 6 times negative 9, negative 63. And then just like we did with the smaller box, we pull out everything, combine like terms. So I have 6f cubed minus 10f squared. I'm just going to go ahead and kind of put the like terms next to each other. Minus 27f squared plus 12f plus 45f minus 63. So my like terms are where? So we got the f squareds. Right. And then the other one would have been 12f and 45f. So we bring down the 6f cubed. Negative 10f squared minus 27f squared. That's the same thing as pretty much 10 plus 27, and slap on negative. So this would be negative 37f squared. 12 plus 45 is 57, so plus 57f. And then bring down the minus 63. And this big boy is our answer. So that one is a little bit more work. Now, you won't, if I gave you one like that, it may be as like a bonus or something. I really only care if you can do a 2x2, but you will do a lot of that one, that type in math 2 and math 3. So it's kind of good to see it now. All right. Any questions? All right. We'll pick this up tomorrow because we only got about 10 minutes left of class because remember, we're out 10 minutes early. So here's your exit ticket for today. I don't care which method you use for that. Just show me that you can get the correct answer. You can use either box or foil. Make sure your algebra tiles go back in the turn-in box with your exit ticket.